Welcome to Rocky Broad Solar, where we encourage you to make the current flow. On today's episode, we're going to go over power control systems in the National Electric Code and how that pertains to solar PV systems and energy storage. Let's get into it. So power control systems was introduced to the 2020 NEC under 705.13. Now that is an additional option compared to 705.11, which pertains to supply side interconnections, and 705.12 for load side interconnections. So essentially what 705.13 does now is it sort of allows you to work around these previous code cycles that were kind of annoying and difficult to comply with when connecting large amounts of solar or batteries to your home. The benefits of using power control systems and avoiding the previous code options are that it prevents expensive electrical upgrades like main panel upgrades or sub-panel upgrades. It complies with utility import and export limitations. So oftentimes the utility is going to say, you can't export more than this amount of power to the grid, or maybe you're not allowed to import power from the grid to charge your batteries, or different utilities have all different kinds of situations and restrictions, and a lot of them are dependent on these transformers as well, so they can be site dependent. So essentially you can kind of program your system to conform to those specific utility requirements. And again, that can prevent transformer upgrades for the utility. So oftentimes if you have a really big system and you didn't have this power control systems in the past, the utility would say, hey, our transformer can't handle that additional export. You're going to have to pay for a $20,000 transformer upgrade in order to connect that to our grid. So PCS kind of allows you to get around those restrictions. So a few of the different types of PCS that are out there. We're going to start with bus bar protection. Essentially this monitors the power coming in from the grid. It monitors the solar being generated. It monitors the batteries being able to charge or discharge. And it just makes sure the combination of all those sources do not exceed the ampacity of the bus bar rating, or essentially that doesn't exceed the electrical equipment on site, overload the system, and cause an electrical fire. So next we've got conductor limiting PCS. I like to call that choke point PCS. Oftentimes that is just complying with the 120% rule, so it's going to measure the conductor coming out of your PV and battery system, and it's going to say, okay, let's not let more than 32 amps come out of this system. So that way it complies with 705.12. Even if the solar and batteries exceed that max amperage rating, this conductor limiting PCS can kind of create a choke point where it prevents the system from backfeeding more than that specified output. Now, you want to avoid this choke point PCS, in my opinion, anytime you can, because oftentimes what's going to happen is it's going to curtail that PV and battery system to make sure that it does not export past that conductor limit. And that's kind of like, defeats the purpose of PCS, in my opinion. It can be used in specific scenarios without really causing any issues, but you do have to really be aware of utilizing that conductor limiting PCS or 120% rule PCS, because it can really cause drastic negative repercussions on the system performance. Next, we've got export limitation. So this limits the export to the grid to a specific amount of power. So again, the utility might say, hey, you can only export 10,000 watts at any given time to the grid, and you can set that export limit into your system so you can kind of use as much power as you want inside of your home, but it's going to monitor those service conductors in the grid, and it's going to make sure your system never discharges more than that limit out to the utility grid. You can also have that export limitation for zero export. So if you're on a utility that doesn't even offer any kind of buyback plan, a lot of people just connect the system, set it to zero export. That's going to allow the solar to produce power. You can use it in your home. You can charge the batteries. You can use the batteries to provide power to your home and kind of use the grid at last resort, but you'll never export to the grid. Now beware, a lot of times that zero export is going to have a little bit of trickle on one single phase to the grid while the grid is operational. You still have no risk of exporting to the grid during an outage, but you can export small amounts of power to the grid while the grid is operational. Lastly, we've got zero export for NEM or net metering add-ons to maintain prior net metering agreements. So a lot of this pertains to California, where say you've got an existing system and you've got a nice one-to-one net metering policy on it that maybe you bought 10 years ago. By adding, but maybe that system no longer really supplies you enough power to provide your home with what it needs. So what you can do now is add an additional PV or PV and storage system onto that site. You can kind of continue letting that existing system export, giving you credits on that one-to-one net metering policy, but you can have that new system and new battery and not export anything and basically just produce and self-consume power in your own home. And that way you kind of preserve that original net metering agreement. Now be aware, places like California, the three major utilities, PGE, SDGE, and SCE, have very specific inverters and their own standards on what they allow in their utility. Some utilities are a lot more strict than others, so you will have to make sure that your specific system has been approved for that NEM integrity. Next, export only and import only pertains only to the batteries, not to the PV system. So, you can basically program it to where your batteries are on export only, where they can discharge to the grid. A lot of people are going to do that where they have really peak demand times, and you can get a lot of credits by discharging power to the grid, during a peak demand time. But in that case, you're not going to be allowed to charge from the grid. And so you can set those export only requirements so it will not import to the battery, it can only export. Vice versa, we've got import only, where you will be allowed to charge your batteries from the grid when needed, but you will never be allowed to export your battery power to the grid. One thing to note is this all revolves around your CTs or your current transformers. So the CTs are installed generally on those service conductors or on the conductors you're limiting the current flowing on. But the CTs, if they're manually installed, they have to be installed correctly. And for those of you that don't know, CTs are a huge point of installation error. Even people that have been in the industry for years commonly mess up CT installation. It takes a real attention to detail and a real skilled electrician to install CTs correctly. And if the CTs are not installed correctly, PCS is not going to operate correctly. It'll cause the system to malfunction. It can cause permanent damage to your batteries. The CTs are just so important and so critical to make this system work as designed. So a lot of manufacturers are moving to have factory installed CTs built into their equipment to kind of eliminate those CT installation errors, but we do still have manufacturers out there sending manually installed CTs, and again, that electrician needs to be on point when they install those CTs in order to make this system work properly. All right, so first we're going to go over power control systems. This is under 705.13 of the 2020 NEC edition. In 2023, they have changed it to energy management systems. So essentially, NEC 2020 says a power control system shall be listed and evaluated to control the output of one or more power production sources, energy storage systems, and other equipment. The PCS shall limit current and loading on the bus bars and conductors supplied by the PCS. For circuits connected to a PCS, The PCS shall limit the current to the ampacity of the conductors or the ratings of the bus bars to which it's connected in accordance with 705.13a through E. So what does this mean? Really, it basically just means we need a nationally recognized laboratory to have certified this power control systems. The most commonly recognized one at this point is the UL 1731 CRD PCS listing, which is an Underwriters Laboratory certification. So in 2020 NEC 705.13a, it says the PCS controller shall monitor all currents within the PCS. Any bus bar or conductor on the load side of the service disconnecting means that is not monitored by the PCS shall comply with 705.12. Where the PCS is connected in accordance with 705.11, the PCS shall monitor the service conductors and prevent overload of these conductors. So what this means is that we need CTs on the line side of all home loads, solar, and energy storage in order for that system to be properly monitored and properly controlled. Otherwise, we're going to have to revert to these traditional NEC rules that can be difficult to abide by. So in the case of using a microgrid interconnect device, you want to put all home loads downstream of that microgrid interconnect device. Both backup and non-backup, especially when they have those built-in CTs, and that way everything's monitored, you're good to go. You do not have to comply with previous electrical code rules. Just beware that some of these are able to manage third-party inverters and some are not. Generally, it's through relays, can also be through frequency shifting, but essentially, if you have existing solar or energy storage on site, and you're wanting to control that through power control systems, you need to make sure that that system is capable. Not all are created equal. So 2020 NEC 705.13d says the rating of the overcurrent device for any single power source controlled by the PCS shall not exceed the rating of the bus bar or the ampacity of the conductors to which it's connected. 705.13e says the access to the settings of the PCS shall be restricted to qualified personnel in accordance with the requirements of 240.6c. So essentially, all the standard electrical code rules still apply in terms of sizing your breakers, sizing your wires, all of that. Like power control systems does not override that. Power control systems just sort of gets you out of the rules that sort of restrict how much solar and energy storage you can add to an electrical system. And also, you can't have these settings to be able to easily be controlled by a homeowner or somebody that doesn't really know what they're doing to go in there and deactivate them or change them, because that can create a dangerous situation. Generally, those settings are going to be restricted to the installer or the manufacturer of the equipment only. So next, in 2023 NEC, this code section has changed to Energy Management System, so it has a new name. So 2023 states an EMS in accordance with 750.30 shall be permitted to limit current and loading on the bus bars and conductors supplied by the output of one or more of the interconnected electric power production or energy storage sources. So the difference here is that we're allowing load shedding to limit the current or limit the load in addition to limiting and controlling the power sources. So this is going to be a big game changer as electrification continues to roll out across the country on these outdated, undersized electrical service and equipment. People are moving to all electric heating and air conditioning. They're installing EV chargers, electric water heaters. But oftentimes you're on these old, outdated 100 amp services, and your feeders coming in from the utility, are undersized, and all of that getting upgraded could be extremely expensive. And so kind of what this allows as well is, you can add large electrical loads in conjunction with an energy management system. And, maybe you have, traditionally you're stuck to doing a load count to say, hey, I have a 100 amp service. I can only have 100 amps of load. Well, with an energy management system, you may be able to have more than 100 amps of load, but that energy management system is sort of going to manage your loads to make sure that at no given time you exceed the rating of the service. So at this point, the most widely recognized certification is UL 1741 CRD PCS. That is a certification requirement decision. Underwriters Laboratories certifies that this system meets all applicable safety standards, maintains grid stability, controls import and export of PV and energy storage systems, monitors and protects conductors and electrical equipment in the home, and maintains that net metering integrity when paired with existing systems. 2026 is coming out with a UL 3141. We already have some utilities adopting this new standard. That will be coming out in the 2026 NEC, and that will kind of override the traditional 1741 standard. So just beware, not all AHJs have the same requirements. We're not all running on the same electrical codes. Depending on what part of the country and what state and jurisdiction you're in, you could be running on codes as old as 2014 where they don't recognize PCS whatsoever. You could be on 2017, 2020, 23. They all adopt these codes at different times, and that's really up to your local authority having jurisdiction. So again, before kind of using any of these codes to design and implement a system at your house, worth checking on what National Electric Code edition your AHJ is working on and what they are going to allow specifically in their jurisdiction. If you're getting value out of today's content, do me a favor, hit the like button, subscribe, press that notification bell, or leave a comment down in the description. As always, I really appreciate each and every one of you. Till next time, take care.